formula of the compound. Okay, how to write the chemical formula of a compound. For example, first before this, let me explain you what is valency. Valency. Okay, and before that, we have also discussed that there are some elements that wants to complete their octet. I have explained you this one in the previous classes. Okay, we have do we have written the atomic mass of first 20 elements? Hmm? Do we have written? Avni, Arif, Abdul Jabbar, we have written. Okay, so I'm just writing the valency. What is valency? What is valency? So we can write, we can say that it is the it is the number of electron gain, lose, or share by an atom to complete its octet, to complete its octet, okay, or duplet is called valency. Okay, for example, like hydrogen, okay, to complete its octet or duplet, okay, or we can say that the number of electron gain, lose, or share by an atom in order to attain the stable electronic configuration to the nearest noble gas, that we have also discussed in the previous classes. Okay, now today we're going to learn that how to write the chemical formula of the compound. Okay, how can we write the chemical formula of the compound? So let's discuss. If we are having sodium, let I'm writing the valency here, valency chart. Okay, valency chart. So first of all, I'm writing monovalent. Monovalent means those ions that is going to have +1 valency. Okay, monovalent. Okay, understood? Understood, everybody? So I'm writing here lithium.
Yes, sir.
Li1 positive is lithium. If I'm writing lithium, here it is name of the ion, and here is symbol. Okay, symbol. So name of the ion is lithium, and it is Li1 positive. Okay. Then next one is sodium. Sodium, it is Na1 positive. 1 positive means it is going to have +1 valency. Okay. Understood? Lithium, sodium, potassium is K1 positive. Then hydrogen. Hydrogen is H1 positive. Okay. After this one, here I'm going to make the second table for this one. Lithium, sodium, potassium, hydrogen. Then the next one is ammonium. Ammonium. That is NH4, 1 positive. This is polyatomic ion. Then silver. Silver is Ag1 positive. Okay. Silver. And then cuprous. Cuprous is Cu1 positive. Okay. Cuprous is Cu1 positive. Okay. So silver is Ag1 positive. Ammonium ion is NH4 1 positive. Okay. NH4 1 positive. Understood? Understood? These are the monovalent having +1 valency. Okay. Got
Yes,
it?
sir.
Note it down. Note it down fast, everyone. Done? Please note this one, okay? Then we will try to how to write the chemical formula. We will learn how to write the chemical formula and how to calculate the molecular mass of the elements, okay? Lithium is Li1 positive, sodium is Na1 positive, potassium is K1 positive, hydrogen is H1 positive, ammonium ion is NH4 positive, silver is Ag1 positive, Cu is 1, copper is Cu1 positive, okay? Got it?
So what is cuprous?
Cuprous is a name for copper, okay?
Is
Copper,
it some kind of an... Oh, okay. I
yeah,
thought it was some alloy.
no, it is not an alloy. It is cuprous, okay? We have two valencies of copper. If it is going to have one valency, we call it cuprous, okay? And if it is going to have two valency, then we call it cupric. This is Cu2 positive, okay? So this you need to remember. When cuprous is 1, then you have to write it +2. And if cupric is 2, then means, for example, it is being asked write the formula of cupric oxide. Then we will take Cu2 positive. If it is asked write the formula of cuprous oxide, then it is okay. And if it is neither cuprous is given nor cupric, only copper is given. And in that case, we will use this one. In copper, we take valency of copper as 2. Okay. Got it? Noted?
Yes, sir.
Noted?
Yes, sir.
Okay. Now moving to the next one is divalent. Divalent means that are going to have valency 2. Okay. Like for example, we have beryllium. Okay. Beryllium is Be2 positive. Then barium, Ba2 positive. Magnesium is Mg2 positive. Okay. Then calcium is Ca2 positive. Okay. Zinc is Zn2 positive. Okay. Noted? Done. Then zinc is Zn2 positive. Beryllium, magnesium, zinc. Okay. Then lead. Lead is Pb2 positive. Okay. Done. Then cupric we have also written in the previous one. I am writing again here cupric. Cupric is Cu2 positive. Okay. The next one is, and we are just writing only +2. Cupric. Okay, cupric. And the next one is ferrous. Ferrous. If iron is ferrous, okay, we call it iron. This is an iron. If it is written here iron like this, S like this 2, iron, and 2 is written like this, it means it is talking about iron 2 positive, and it is considered to be as ferrous. We called it ferrous. Okay. Sometime it is being written like the formula of iron oxide, iron, and then it will be written like this, and then oxide. So what is the formula? It's in this, when it is written like iron and it is written like 2 here, then it means that it is talking about iron with valency 2. Okay. Okay. That is
Yes,
Yes, sir.
sir.
Fe2 positive. And sometimes it is written ferric, ferric, and it is Fe3 positive. Okay. 3 positive. So it means iron 3 will be written sometimes. Okay. Iron 3 like this. Okay. And this will be Fe3 positive. Got it? Got it?
Yes, sir.
Then
So,
after this one, this is ferrous, this is ferric, this is Fe3 positive, this is Fe2 positive. So if it is being asked ferric, now you remember that ik is more and us is less. Like for example, copper Copper has two types of valency, 1 and 2. So us is 1 because it has less 1, okay? Less number is 1, okay? For this copper has only 1 and 2. So us is this one and ik is this one, okay? Similarly, in ferrous, means in iron, it has 2 and 3. 2 and 3. So 3 is ik, and here us is 2, okay? Understood what I'm saying? Ferrous 2, ferric 3. But in copper, ferric is 2 and ferrous is 1. Okay, because copper has 1 and 2. But iron does not have 1. It has 2 and 3. So 2 is less number for iron. But in copper, 1 is less number for copper. Okay, because it has 1 and 2. But iron has 2 and 3. Okay. So us, ferrous means +2 and ferric means +3. Okay. Understood?
Yes, sir.
Beryllium, barium, magnesium, calcium, zinc, lead, okay, cuprous, ferrous, ferric, okay. Then we have mercury, Hg, mercury,
So we don't learn the valency of the table 4.1.
you have, that this you can learn from that one also, the same that I'm writing, but there are some elements that are not written there, but these are important. So you have to memorize this table. That is very important, because if you learn this table, that this valency chart properly, then let me remind you that you are going to learn more than 70% of the chemistry by this table, because this table will help you to learn the chemical formula of the compound. If you learn this table, you will be able to write the chemical formula, and then you will be able to write the chemical equation in the higher classes. So this is must that you must remember this one, and you can learn this one by practicing more and more question. Okay, you cannot learn it like if you start learning this, you sit there and you start learning. This is not possible. You have to memorize this one by just practicing. Okay, this is Hg. Hg is mercury. Okay, and the next one is, now this is 2, and now we're talking about trivalent. Okay, leave some 1 or 2 lines if I miss anyone, then I will write it here. Okay, for the 2. So don't write it, start writing 3 just after this one. Leave 2 or 3 lines. Okay, if I left anyone, then you can write it there. Okay, now the next one is, trivalent. Trivalent. If I'm talking about trivalent, is valency with +3. Okay, and this is aluminium. Aluminium is going to have +3 valency. Okay, got it? And that is Al3 positive. Only aluminium is going to have, that we are going to have in our syllabus. Okay, the next one is tetravalent. Tetravalent, that is going to have, and like I have written trivalent, only aluminium. Then ferrous, ferric you can also write here, ferric, Fe3 positive. Okay, ferric. Then tetravalent is, that is going to have +4 valency, and that is carbon. Carbon has +4 valency, C +4, and we can have silicon also. Silicon is Si, and that is also going to have +4 valency. Okay, let me remind you that there are some elements that also show variable valencies. Like for example, I have written lead as Pb2 positive, but it sometimes show Pb4 positive also. So that is an exception case that you're going to study in the high classes. No need to learn this one here. Okay, written.
Okay.
Written, everyone. Written, everyone.
Yes, sir. Done.
Yes, sir, done.
Okay, let's move further. Now we have written the positive one. Now we are just writing monovalent. Monovalent again.
So
Then
can
with,
I see the previous slide for a minute?
yeah,
I was on the, yeah.
this
No,
one,
the next one.
this one,
Yeah. No, the next one.
this one.
Yeah.
Noted. This is very important. Every student must remember this one. Okay.
Done, sir.
Okay. The next one is monovalent. Monovalent with negative -1 valency. Okay. that is going to have -1 valency. Okay. So we're going to write fluorine. But fluorine is a name of element, but when it become negatively charged, like fluorine is a gas. For example, this is F, and when two FF fluorine atom combine together, they form F2 molecule. Like Cl, two Cl atom combined together, they form chlorine molecule. But when they are going to have charge, they become chloride. Instead of fluorine, they become fluoride. Okay. When the negatively charged ion, for example, this is an oxygen atom. These are two bonded together, they are forming oxygen gas. Okay. Two oxygen atom when combined together, they form oxygen gas, O2 molecule. But you know that oxygen is going to have 6 electron in its outermost shell. And if you don't remember this one, so let it be, because we have not studied structure of atom. So let me remind you that it is going to have 6 and it want to complete octet by having 2 extra electron. So it will form O minus 2 by having 2 extra electrons. So this oxygen atom, when it is going to have -2 charge, it will become oxide. Similarly, if it is chlorine atom is Cl. And if it is going to have -1 charge, then it becomes chloride. Similarly, fluorine atom is only F, but if it is going to have -1 charge, then it is going to become fluoride. We pronounce it fluoride. Okay. So we will write it like this: fluoride, chloride, bromide, iodide. Okay. Oxide, nitride. We don't write it.
Yeah.
Okay. We don't write it nitrogen. We don't write it fluorine like this way. We don't write it. Okay. So wait a minute. Okay. So if I'm having fluoride, so you will write fluoride, and this is F-1. Okay. Then this is chloride. This is Cl-1. Okay. Chloride, and this is Cl-1. Then bromide, that is Br-1. Then iodide, I-1. Okay. Then fluoride, chloride, bromide, iodide. Then we have some polyatomic ion that is going to have, polyatomic means that are going to have more than one valency. Okay. Sorry, they are going to have more than two atoms combined together. They are called polyatomic ions. What are polyatomic ions? Polyatomic ions means they are going to have more than one atom. They are combined together. For example, OH, hydroxide ion, hydroxide. Then hydroxide is OH minus 1. Hydroxide is OH minus 1. So OH, you know that O is going to have -2 charge, and H, hydrogen, we have written previously, that is going to have +1 charge. So togetherly -1 and +1, when they are added together, they are going to have -2 and +1. It is going to have -1. Okay. Understood? O, you know,
Yes, sir.
O has -2 charge and H has +1 charge. So -2 and +1 will get you -1. Hydroxide. Similarly, hydrogen carbonate. Okay, this is H. H is for hydrogen, and carbonate group is CO3. We called it CO3 as hydrogen, and carbonate is CO3 only. Okay. So when they mix together, they're going to have -1 valency. Okay. Got it? Can you
Yes,
tell
sir.
me, what should be the valency of this carbonate ion? What could be the valency of this carbonate ion?
-1.
-1. -1 is togetherly with this one. So you know that if it is X carbonate ion and you are going to have H with this, it is going to have +1, and togetherly they are going to have -1. Okay. Means if you don't know the valency of this carbonate ion CO3, then consider it as X. Okay. And this one has +1, because you know hydrogen is going to have +1 valency. So 1 plus X is equals to -1. So it will go to that side. X is equals to -2. Okay. And you are very much familiar that if it is 1 and this is -2, hydrogen has only +1. and carbonate ion is going to have -2. So when you add these together, you will get HCO3 -1, okay? Because this will sum up,
Okay, sir.
this will sum up and will give you -1, okay? Okay, got it? So this is how we calculate the valency of a polyatomic ion. And you have to memorize this one, that hydrogen carbonate is HCO3 and its valency is -1. Okay. Now hydrogen, if I'm talking hydrogen, so hydrogen is going to have if is going to have +1 valency. But if it is hydride, hydrogen sometimes borrows one electron to complete its duplet, like to have its completely filled shell. Okay, let me explain you that this is the hydrogen atom. Okay, this is the hydrogen atom. It is going to have one electron and its atomic number is 1. So when it loses one of its electron, it forms H1 positive. And when it is going to have, when it borrows electron from somewhere, and it is going to have 2 electrons, like to attain the helium electronic configuration, that is of noble gases. That means the first shell can accommodate only maximum 2 electrons, so it wants to have 2. So if it borrows 1 electron from somewhere, then it will become hydride and will become H-1. Okay, so when hydrogen is there, then we take H positive, like we have written here. Hydrogen, this is hydrogen, and it is going to have +1 valency. Okay, okay, you understood? And where we are writing hydride, we are writing hydride, and it will be H negative. Okay, got it? For example,
Yes.
if the formula is being asked hydrogen sulfide, to write the formula of hydrogen sulfide, then hydrogen we will take +1 and sulfide we will take -2. We will learn that sulfide is going to have -2. The formula will be written accordingly. And if it is being write the formula of sodium hydride, then we will have sodium as +1 and hydride H as -1. Okay, understood?
Yes, sir.
So when it is being hydride, then it means H minus. When it is being as hydrogen, then it is H plus. Hydrogen chloride, okay, then it is hydrogen. Okay, understood everybody? Understood? Nobody is replying.
Yes, sir.
Okay. Now one more polyatomic ion that is going to have +1 valency. Sorry, -1. Hydride, hydrogen carbonate. Then we have ammonium, we have done. Hydrogen sulfate. Hydrogen sulfate. Okay, that is HSO4. HSO4. Hydrogen sulfate. HSO4. Okay, this is also going to have -1 valency. Hydride, hydrogen carbonate, hydroxide, hydrogen sulfate. Okay, so sulfate must be having -2, and this hydrogen is going to have +1. So togetherly they are going to have HSO4 -1. Okay, understood?
Yes, sir.
Yes,
Okay.
sir.
Okay. So have you noted this one, everybody in the class? Have you noted?
Sir, 1 second. Just the last thing.
Okay. NO3, nitrate. This is very important. That one I'm just thinking. Nitrate ion. Nitrate. Nitrate. Okay, that is NO3 -1. Nitrate. And acetate ion. Acetate. That is CH3COO and then -1. Is the formula CH3COO -1. This is the last one. Acetate, ACE, single C is there, not double C. Noted? Everyone, acetate.
Yes, sir.
Okay, should I move forward?
Yes, sir.
Okay, next is divalent but in -2, okay? Divalent in -2. So that is oxide O-2. Oxide and sulfide. Sulfide is S-2. Okay. So oxide O-2, sulfide S-2. Then we have what? Then we have polyatomic ion that is going to have polyatomic ion that is going to have minus, like we have discussed, sulfate. Sulfate, if it is not, if it is hydrogen sulfate, then it is going to have -1. But if it is only sulfate SO4, then it is -2. Sulfite, IT, this is SO3 -2. Both are going to have the difference of oxygen, but their valency is same. Let me remind you here that even if it is sulfide, IDE is single. IDE represents single atom. Okay. ATE, oxygen with extra oxygen. ITE, oxygen with less oxygen than sulfate. Okay. This is going to have 4 oxygen atom. This is going to have 3 oxygen atom. Okay. But they all of them are going to have -2 valency, whether it is sulfide, whether it is sulfate, but you have to remember the correct formula. Okay. Don't forget the formula in which is SO3, which is SO4. Okay. Got it? They are going to have same formula. The next one is
Yes, sir.
Carbonate. Carbonate is CO3 -2. If it is hydrogen carbonate at CO3, then it is going to have -1 because this +1 and -2 will togetherly form. Okay. But if it is only carbonate, then it is -2. Okay. And if it is hydrogen carbonate at CO3, then it is -1. Okay. Carbonate is CO3 -2. Then I'm just writing this one because you will learn this one in the 10th standard also. So I'm writing 2 extra, which is not going to come in your examination in 9th standard, but in 10th standard, it is very important. So I'm just writing here. One is zincate. Zincate, that is ZnO2, that is -2. Okay, ZnO2 is zincate ion, and it is going to have -2. Okay. So carbonate we have done, sulfate. Okay. So oxide. Now moving to the next one, that is going to have -2. Sorry, -3. Noted everybody this one? Everybody noted? Romaisa? So let's move further. The next one is, third one is trivalent. Trivalent means with valency -3. Okay. -1. That is phosphate. Only the nitride ion is there. That is single atom that is going to have 3 valency. -3 nitride, that is in -3. Other are polyatomic only. Polyatomic, that is phosphate, ATE, okay. AT means 4, -3 valency. And we have phosphite. Tell me what should be the formula of phosphite? What should be the formula of phosphite? If phosphate is going to have PO4, what is the formula of PO phosphite? ITE. Then it is going to have PO3, 1 oxygen less. If it is 8 is going to have 4 oxygen, then it is going to have IT is going to have 1 oxygen less than phosphate. Okay. So then, but the valency is still same. Both are going to have it, whether it is PO4, it is PO3, they both are going to have valency as -3. Okay, understood?
Yes, sir.
Now in -4, we don't have anyone, uh, uh, any atom that is going to have -4. Like we have carbon and silicon that is going to have +4. So okay, so that's all for this one. Now let's have you noted everyone. Romaisa and some students have joined late. So if they have not written this monovalent, so please note it down here. Note it down this one. Lithium, sodium, potassium, hydrogen, ammonium. This is not aluminium. That I'm telling you, this is ammonium ion. Okay, it is NH4 positive one. NH4, ammonium, silver. So if those who have not written, please let me know. Is there anyone who is still writing this one? The first one, monovalent.
No, sir. Done.
Done. Okay. So let's you write the how to write the formula now. Now coming to the point that how to write the chemical formula of the compound. So when we are writing the chemical formula of the compound, what we need to do is we need to write the positive valency first and then negative valency one. For example, if it is being asked, write the formula of ammonium chloride. Ammonium chloride, sodium sulfate, calcium phosphate, calcium phosphate, lead, lead sulfide, cop, cupric oxide, ferrous, ferrous, ferrous oxide. Okay. So how will you write the name of the formula? How will you write the formula for this one? So let me explain you. So if I'm having this one, ammonium chloride. So ammonium is NH. Okay, ammonium is NH4 positive, and chloride is Cl minus. Okay, they are both are going to have -1 valencies. Okay, both, sorry, this is going to have +1 and chloride is going to have -1. So when they are going to have same like 1 1 2 2 3 3, then we cancel out each other. If it is 1 1, then it is okay. For example, if you're having calcium oxide, write the formula of calcium oxide. So calcium is going to have 2, that you can check it from your notebook, and oxide is also going to have 2. So when they are going to have same 2 2 3 3, then we cancel out each other and we write the formula CaO. Similarly, if we have 1 1 here, then we cancel out each other and we will write we will write NH4Cl. Okay, got it? Got it?
Yes, sir.
Okay, so the formula for ammonium chloride is NH4Cl. Formula for sodium sulfate, for example, sodium sulfate. Sodium is Na, it is going to have +1 valency, and sulfate is SO4, it is going to have -2 valency. So what we will do, we will give this to this one and give this to this, or you can write it like this way, +1 and sulfate ion is -2. Don't write minus and plus here. This is, don't write like this. It's okay. Okay. Then just cross multiply this. Okay. Then we're going to have Na2. Don't write 2 like this way. Don't write like 2 like this way. Write 2, the valency 2 here, like small, like this way. Okay. And then SO and then 4. Okay. Because this 1 is going to multiply with SO4, then it is SO4. It will remain SO4. Okay. Got it?
Yes, sir.
Now talking about the formula for the calcium phosphate. Calcium phosphate. This is the formula for second one. This is the formula for first one. 1, 2, 3, 4, 5, 6. So if I'm talking calcium phosphate, now talking this is important. Calcium is going to have 2 valency and phosphate is PO4. That is going to have 3 valency. Okay. Phosphate is PO4, that is going to have +3 valency. So when you cross multiply these two, so right, you will write Ca. This is same, since calcium is single symbol of a calcium element, so you will write Ca3. Okay, but PO4 is not a single element. It is phosphorus and oxygen. And you have to multiply this by 2. So don't write it 2 like this. You have to keep this in the bracket like this, whole and this 2. If you write it like this, Ca3, PO4, and then 2, it will be incorrect. You have to write in the bracket, okay? Got it? Because it is a polyatomic ion, PO4. So this 2 means now this 2 is being multiplied with oxygen. This 2 is also multiplied with phosphorus, okay? Got it?
Yes, sir.
Next one is, this is the formula for the third one. Now the fourth one, lead sulfide. Lead is Pb and sulfide, IDE, not sulfate, not sulfite, ITE. It is sulfide. IDE means single element. So this is sulfur. Pb is going to have 2 valency and sulfide is also going to have 2. When they are going to have same, that will cancel out each other and will form PbS. Okay. Okay. Is there anyone who didn't understood this one? Prishita? Understood?
Yes, sir.
Now, next one is cupric oxide. So if it is being asked cupric oxide, cupric, ick. So cuprous is, copper has 2 valency. If it is us, then it is going to have +1. If it is ick, then it is going to have +2. So cupric. So cupric oxide is Cu is going to have 2 valency. Oxide is also going to have 2 valency. Then you cancel out each other. This is CuO. Next one is ferrous oxide. Ferrous oxide similarly. Iron when it is ferrous. Copper when it is cupric, then it has 2. But iron when it is ferrous, then it has 2. Okay. You have to keep in mind that iron when it is ferrous, then it has 2. But copper when it is cuprous, then it has 1. So it has 2 and oxide is going to have also 2. Then they will cancel out each other. The formula will be FeO. So this is the formula for ferrous oxide. And this is the formula for cupric oxide. So ick in copper is 2, but us in iron is 2. Okay. Understood? Understood? Noted? Noted, everybody?
Yes, sir.
So I'm going to give you the, you have to write the formula for some compounds. I'm just going to give you for practice. Wait a minute. Okay. Write down the molecular formula of these compounds that I'm writing. Sodium, carbonate, calcium, sulfate, potassium oxide, hydrogen, sulfide, hydrogen, phosphate, phosphate, it is also called phosphoric acid, phosphoric acid. Okay. Next, sixth one is hydrogen sulfate. This is sulfuric acid. Okay, don't write it, hydrogen sulfate. Next one is lead nitrate. Nitrate. Next one is aluminium nitride. Nitride 6. Sodium zincate. Zincate. Next one is ammonium sulfate. Ammonium hydroxide. Ammonium hydroxide. 11th. Calcium hydroxide. With the help of, I'm just giving you 10 minutes. With the help of the chart that you have written, write down the formula of the following compounds, okay?
Yes, sir. With the valency?
The valency that we have given to you, that you have written in your copy.
Okay, sir.
Okay, please note down the formula of this compound. Take the help. Done, everybody?
No, sir.
Okay. Write it. Done, everyone? Done?
So the last 5 are remaining.
Okay. Do it, do it.
Yes, sir.
Well done.
Sir, done.
Okay. So let's you check the formula for sodium carbonate is Na2CO3. Okay. The formula for calcium sulfate is CaSO4. Formula for potassium oxide is K2O. Hydrogen sulfide is H2S. Because when it is saying hydrogen, we take hydrogen as +1 and sulfide is -2. You cross multiply, you will get H2S. Okay. Then hydrogen phosphate is H3PO4 because hydrogen is +1 and phosphate is PO4 with valency 3. You cross multiply, you will get H3PO4. Lead nitrate is PbNO3 whole twice. Aluminium nitride is AlN only because aluminium has 3 valency and nitride IDE. It is also N. It is going to have 3 cancel AlN. Okay. Sodium zincate is Na2ZnO2 because sodium is going to have +1 valency and zincate is ZnO2 is going to have -2. You cross multiply, you will get Na2ZnO2. The next one is ammonium sulfate. Ammonium sulfate is NH4 whole bracket 2 and then SO4. Why? Because ammonium is NH4 that is going to have +1 and SO4 is 2. Okay, when you cross multiply, you cannot write it like NH4 2. No, you have to put this as a whole in bracket because this is a polyatomic ion. When we are just going to multiply, cross multiply a polyatomic ion which is going to have more than one items, we just keep that one in bracket like this. Because one is when it is going to multiply, we don't write it in bracket because this is only one. Okay, so this is NH4 whole twice then 2. Okay, the next one is ammonium hydroxide. Ammonium hydroxide is NH4OH because both NH4 and OH is going to have +1 and -1 valency. Calcium hydroxide is CaOH whole twice. Okay, calcium is going to have 2 valency and hydroxide is going to have 1. When you cross multiply, we write Ca1, don't write 1 here, and then OH, and don't write 2 here because it is polyatomic ion, so write it in bracket. Okay. Okay, is there anyone who is still writing and who have doubt that how this formula has come? Is there anyone who wants to ask that how you have written this formula?
Sir, miss, how did it?
Which one? The valency chart that we have planned?
No solution. CaO.
CaO.
Yes, sir.
Where is CaO? Calcium
Sir,
oxide. Where is
calcium.
C?
Calcium.
Calcium hydroxide. Which one? 1, 2, 3 number? The formula number? You're asking about how to write the calcium oxide, CaO.
Yes, sir.
Ca is going to have 2 valency and oxide is also going to have 2 valency. When both are same, we just cancel out each other. And then we mix them. We write it CaO. With the H2, 2 will cancel out each other. Okay? Don't write Ca2.
So no need to write Ca2O2, right?
No. They will cancel out each other. Likewise, if we are having sodium chloride, it is going to have 1. Chlorine is also going to have 1. You cross multiplied, you will get NaCl. Okay? Don't write like this way. 1, 1. Okay? And if I'm going to have same one, then we cancel out each other. Okay? Okay? Understood,
Okay.
Ramaisa, Abdul Jabbar, Avni,
Yes, sir.
Parishita.
Yes, sir.
Is there any doubt regarding to this one?
No, sir.
No. Okay. So that's all for today. We'll meet you in the next class. Okay, we have learned the formula, and last topic from this chapter is just to write the molecular mass of the compound, because mole concept is not in the syllabus. We will learn the mole concept when we have finished this chemistry chapter as a whole. Then we will learn at